Hello everyone, thank you for joining and welcome to today's webinar. We're going to focus on essentially an event-driven architecture for trading applications, particular focus on the capital markets and electronic trading. My name is Dave Carson. I look after field engineering and professional services for Push Technology, and we will just make a start on our presentation. So we'll have time at the end for questions as well. If there are any questions during the presentation, by all means, feel free to raise your hand and we can go through any questions that you may have. So a little bit about the the agenda for today. So we're going to look at an example electronic trading architecture, if you like, just a sample architecture diagram to set the scene of what we're referring to when we talk about electronic trading. Looking at the audience here, I think it will mean a lot to many of you already. It'll be very familiar, and we will be using that architecture as we progress through the presentation. We will look at some of the technical challenges that are faced in electronic trading, but we will focus particularly on three areas. The first is this consumption of source data. It could be market data or internal systems and so forth. We will also look at how the challenges of actually enriching and transforming data. And then we will look at how to distribute data securely and efficiently over either internally across an institution or externally to your clients and so forth. So without further ado, if I may just introduce the example architecture of electronic trading that we will be using for the premise of this webinar. So this diagram we'll be using this a couple of times throughout today's presentation. Very briefly, I will just mention, I'll just describe it, although I'm pretty sure it'll be very recognizable to many of today's audience. So essentially, starting at the top left, we'll have, let's say it's market data that could come from exchanges or alternative trading system. It could be brokers, it could be third-party fee providers and so forth. But ultimately, it's market data, and it is consumed into the electronic trading platform, usually by a suite of, say, feed handlers that normalize the data and then publish it over a normalized backbone. Down towards the bottom left, we then have our range of traders or trading desks. They will have their own OMSs, if you like, order management systems, consuming the market data. They'll have EMSs and execution management systems, which they will use to work the orders as well. They will send executions out through essentially an execution messaging bus, which will use, potentially optionally might use a suite of algorithms or algos to decide when to send orders to the markets. And there could even be something like a smart order router which decides where to send orders. And then the orders are sent back out through market access gateways back to the exchanges or brokers. And the loop is repeated, if you like, in the form of market data coming back down again. Of course, as executions happen on the street, it's important that they are filtered down to the likes of middle office systems for accounting and updating risk management. And also there is potentially institutions may open up their systems to their own clients to route their orders electronically through, like the buy side, if you like, could route their orders through the platform and through potentially FIX or other binary protocols. So I'm sure this will be very familiar to many of you in today's audience, and we will be using this a couple of times throughout the presentation. So first of all, we will look at some of the technical challenges and where diffusion can help solve problems. So first of all, there is the consumption of market data. Market data, as we know, comes in many different protocols. It can also be very voluminous in terms of very high volume. Diffusion can very efficiently consume data, but also using diffusion to model the market data that we'll see in today's demo. It will be possible to even filter data down so that essentially we're only publishing or distributing the data that is needed for each application's needs. So as opposed to just consuming a big pipe of multicast and sending it out to everybody, it's possible to efficiently consume that data and then distribute it out much more efficiently. Furthermore, then we have the challenge of feeding our traders' desks. I myself have worked on a trading floor, and I've encountered many times traders' desktops getting slow because the data is just too high volume. They're receiving every single tick, even though they're not interested in many of the instruments. Maybe it's a different currency, or maybe it's a country they're not registered to trade in, and so forth. So there is the problem of getting the right data to each of the individual traders' desktops. Then we have the problem of receiving our client order flow. So how can we do this in a secure fashion? Historically, maybe we needed lease lines and so forth, but that doesn't necessarily scale. So how can we do this securely and efficiently over even public lines like the internet, for example? Then we have a challenge of taming what we'll call the flood of data, of internal data pipes. We ourselves at Push Technology have seen clients engaging us because they essentially have a flow of data that is so high in volume that it's crashing their systems. So they've asked us to help them solve this problem by disaggregating the data, taking the fire hose of data and splitting it up into smaller feeds, so that only the data that the applications need is sent to them. They're not inundated with unnecessary data. Then we have the challenge of how do we keep our algorithms, etc., up to date with real-time metrics? How can we feed them efficiently without them having to subscribe to, again, a full stream of unnecessary data? And then there is the secure connectivity to our brokers. How can we have secure lines to be able to send and receive messages from our brokers? So these are 6 technical challenges that we see in almost sort of I would say many electronic trading platforms, and I'm sure for many of you here today that these problems may resonate. So what we will then focus on today is we will focus on how Diffusion can help solve these issues. We will cover in detail. We will look at flexible data consumption, how we can consume data from high volume sources and distribute this in real time. We will also look at how we can enrich and transform the data, potentially even to extract value where it isn't there in the raw data. We can create a new view of the data, which adds further value to our offering in terms of what services we offer to our clients. And then finally, we also have we'll also focus on the secure and reliable delivery of data over the internet. So how can we send high volumes of data over public networks like the internet? So without further ado, we will just briefly introduce Diffusion. Diffusion is primarily split up with three pillars. There's the first pillar is the consumption of data. Today, Diffusion off the shelf comes with a range of adapters already integrated into the product. Like, so we see them on the left: Kafka, MySQL, Redis, and Cassandra. And the consumption of data, we will look at how we can efficiently model the data such that we can pick and choose what data we wish to forward on. With the second pillar then is what we'll call our data wrangling. This is where we can transform data to meet your client's needs. As I said, we can extract value where maybe it doesn't exist in the raw data. And then we will look at the data distribution. This is how we use the most efficient distribution mechanisms to achieve over 90% reduction in bandwidth. So this opens up the possibilities of distributing your data over on public networks and unreliable networks like the internet or mobile phones and so forth. A little bit more about our deployment models and delivery mechanisms. So Diffusion today is available either as on-premise or in our own cloud. We have the Diffusion available in our own AWS cloud, and it can also be deployed in a hybrid model as well. So there are multiple ways that Diffusion can be deployed. We will look through our APIs and the SDKs, which are extremely feature rich. And we'll also look at the adapters. In fact, we demo the Kafka adapter. And again, all of these are available off the shelf within the product. And then we'll also touch upon the different streaming methodologies that can be used to interface with Diffusion. So there's the streaming, publish, subscribe, where you subscribe, you receive all the streaming updates. Diffusion also supports request response, the likes of REST and so forth. And it can also be even used as a messaging platform, whereby you can send a message to particular consumers and so forth. So Diffusion itself supports many different messaging methodologies. Now, a little bit about, before we continue, I think it's important to mention about the performance of Diffusion. So here we have some sample performance statistics run by our own benchmarking team. And this was run on an i7 core laptop, the MacBook Pro. The point the sample statistics we have here is that 1,000 messages per second over 10,000 topics with a message size of 1 kilobyte, which is probably quite large, to be honest. Most messages potentially a lot of messages in electronic trading wouldn't be so large. But we are achieving a median latency of sub-millisecond with a P99 of under 5 milliseconds. And there are further tuning available here. This is depending on the requirements of a deployment. These are statistics that we're very happy to publish because it's very easily achievable on a standard commodity laptop, if you like. The point we're making here is that Diffusion won't necessarily cater for your single-digit microsecond algos or even nanosecond algorithms, but it can sit on the performance critical path where, say, sub-millisecond is acceptable. And there are many applications within an electronic trading platform where all it's needed is sub-milliseconds. The single-digit micros isn't necessarily a requirement. So we won't necessarily feed those microsecond sensitive algos, but we can cater for the other over 99% of electronic trading applications that require real-time streaming data. And then just a little bit about the adapters that are available off the shelf. So Diffusion comes off the shelf with its REST adapter. We've mentioned real-time databases. We can also interface with via JNX. It supports Apache Kafka, and there are many more adapters available on the roadmap. In fact, our clients actually are able to build their own adapters, and it takes approximately 1 to 2 days to build a resilient control client. By that, I mean a fully redundant application that can form a resilient pair, available by the APIs. It's all built into the control client API, and it takes approximately 1 to 2 days to build an adapter that will take your internal feeds into a Diffusion deployment. So a little bit more, if I may, just talk about data modeling. So what is data modeling and why do we need it? Data comes in many, many forms, and in order to make the most of the data and to ensure that all the clients get all the data they need, but not necessarily inundate them with unnecessary data, we need to take a structured approach to looking at what data we actually have. So there are different things that we may do under what we call data modeling. The first of these is disaggregation of data. So we can take a pipe of data available like on market data feeds is a good example. And we can disaggregate that into segments. And then we can send those segments to allocated users as we define in our permissioning model, which we'll touch upon very shortly. We also will we can configure which users are entitled to see what data. So this means that we're not sending unnecessary data. It also means that we may, for example, we can abide by regulations where, for example, certain data must stay within certain jurisdictions and so forth as well. So we're only sending what is needed and where we need to send it to. There is, of course, the problem that there are different types of data. So there are numeric data, text or strings, JSON, there's binary data and time series data, and Diffusion supports all of these off the shelf. And then there's, of course, how to control access to the data. So we will look at the permissioning model and how Diffusion's APIs can integrate with our clients' single sign-on systems and so forth to, at a very granular level, we can determine exactly which users are receiving what data. And this is all done in real time. No need for overnight caches or weekend changes and so forth. It can be done in real time. The summary of all of this is about data modeling is about getting the right data to the right consumers. So in terms of, okay, we've got lots of data, then we will introduce this concept of what we call data wrangling. Data wrangling essentially refers to how we have structured the data. How can we then derive different views or transform the data or enrich the data to create, say, additional content that maybe isn't available on the raw input. So that's what we mean by data wrangling. And here we're introducing our first topic tree. So for those of you who are familiar with diffusion, you'll be aware of topic trees are essentially a structured approach to data. Here we see we've got two asset classes. We've got commodities with two sub nodes. We've got FX, three currency pairs, and we see our Aussie dollar here has three different tiers of prices. So we have a tier 0, 1, and 2 with an increasing spread. So 0 being the tightest spread, 1 the middle, and 2 being the worst, of course. So this is an example of a topic tree, and we can permission every user at any node. So we can permission them at the root or any of these nodes where they can then see everything underneath. And we will see, and it's worth highlighting as well, if a user doesn't even have the ability to see the data, then it is hidden from them. So for example, a user has to be granted access to even see a node, or else they won't even know it's there. So data can be hidden from users. They won't even see the content, the topic tree structure, unless they have the permissions to be able to see it. And we will see that actually in a quick demo very shortly. This, when we talk about data wrangling, ultimately we're talking about Diffusion's ability to use what are called topic views. Now, topic views are essentially it's a declarative rules for creating new views of the data based upon what is being input into Diffusion. In terms of how they can be created, they can be entered in using the management console, which we will see shortly, or they can be coded via API as well. That means they can also be changed and modified in real time. So a topic view is taking a source of data, a source view of the data, and is presenting a new view of that data in real time. These topic views can be dynamically changed and so forth, and through the APIs. One of the main points around topic views is that we are not actually copying data around the place. We are actually referencing the original data source. We are just presenting a different view of the data. So because we aren't copying data, that means that there is less overhead, and therefore topic views add very little processing overhead on the diffusion system. This means that we can create topic views, we can create views of views, we can cascade them, and we're not putting a lot of pressure on the diffusion system. Furthermore, a new topic view is also subject to the security controls of the standard diffusion permissioning model. So we can create views of data, and we can grant users access or deny users access to that data. In fact, we were speaking last week with a customer around topic views who they described it as virtual pointers or topic pointers, which I think is a great way of referencing a topic view. It's we're not copying objects around in memory. We are literally referencing the original store. As it updates, all the topic views update as well. So it's extremely high performance. So a little bit around what data we'll be using for a demo today. We are using FX data. It's JSON, as we can see, and it contains an array of 10 currency pairs. And each currency pair has an array of 3 prices with increasing spread. So there's tier 0, tier 1, and tier 2. So this is our raw data, and we will be loading this into Diffusion just as it is. And then we'll be using topic views to create different views of the data. So a little bit around exactly what the views we're going to show. So as we're pulling in this raw data, and here is our first topic view at the bottom here, we see we are mapped, take the incoming data. So this FX will literally store the original data. And we are using this topic view, which uses the expand function, which looks at an array or JSON object and will expand the data out into their own topics. So we look at the incoming data and create a new view, which we call currencies, and then pull out the content. So here we create underneath currencies, we will have our 10 currency pairs. And we can go further than this then. We can then apply a view onto our currencies. So recall that the currencies is literally a view of the data. It doesn't exist in the raw form. It's being created dynamically by Diffusion. But we can apply another topic view to this, and we can then expand it again. This time we use the path, means pull out the path, the value, which would be so it's currency / currency name / so that's what the path 1 references. So use whatever's there and then expand out the content. So this then gives us a new view of the data, which we call tiers, where we have each individual currency pair and then the 3 nodes. And this will only contain the pricing data for that tier. So now we're able to split apart the data, and we have a view of currency pairs, and then underneath each currency pair, the 3 different pricing tiers. But then what we can do is so that we can then apply another topic view to our tiers view. And this time, we'll map the tiers view, and we create a new view called by tier. And we use the path function again, but this says take the second item and only one of them, and then take the first item and only one of them. And what we end up with is by tier, we will end up with by tier, then the pricing tier itself and the currency pairs. So what we have now created is we have created the ability to enable clients to only receive certain tiers of the data. So we can subscribe clients to only the top tier, or only the middle tier, or only the bottom tier, where this view of the data does not exist in the raw form. So using topic views, we have been able to create a view of the data that is not available in its raw form. And a little bit more around, it's not just topic views are not just limited to expand. There are other functions available, such as using scalar, which means take the value of the data and create a topic using the value of what's in the data. We can use the value function, which will take a segment of a JSON object and to inject it into another JSON object. We can also use what we call throttle and delay. Throttle will mean that only a certain number of ticks are sent through over any time limit. So sending one update every 5 seconds, or we can delay the feed as well, delay it by 5 minutes and so forth. So we can create a view of and we can mix and match, we can throttle and delay as well if we wish. So we can create views of the data, for example, that are delayed by 15 minutes, which means that we have applications that don't have to pay the exchange fees because they're delayed by a certain period of time and therefore they're exempt. Similarly, we can also throttle data feeds so that they're not like maybe websites and so forth, where they're not actually receiving every tick. They're only receiving every 10th tick or so forth. So they're not being inundated. So, and a little bit about other modeling techniques. So I've showed what can happen around when we look at the tiers of FX prices. But when we use our imagination, there are different ways that we could model our data, our market data. So the first one is, for example, we could do it by MIC code or market identifier code. So, we could easily create a view of the data where we just have individual markets. So here we have, for example, these are the US, some US exchange MIC codes. We could also do it by regular expressions. So topic views allow us to use regexes, and we'll demo that later. So we could maybe do it by, for example, by the first 2 characters of the ISIN, which means that we break it out into their individual country codes. We could also do it by, say, for example, comp ID. So this is where we have fixed order flow, for example. And we can have it by sender comp ID, target comp ID. We could even use our scalar, for example, on the client order ID to create a view of the lifetime of an order. If we combine that with a time series topic, then we would have Diffusion keeping every fixed order and the whole messages associated with that order. Everything from the 35 equals D through to the partial fills, through to the fully fill and done per day, things like that. So all of this can be done just by using topic views in Diffusion. Or we could also do it by message type. We could, for example, just send down the orders, just send down the reference data, or even the security status messages. for those algorithms that need to know what the state of the market is, or just maybe the trades. Again, just for our middle office systems, maybe they're only interested in the trades. Crucially, however, all of these can be done in real time via topic views and programmatically as well. They can be modified as well on the fly as needed. So now I'm just going to do a quick, bear with me, I'm just going to share my screen. I'm just going to do a very quick demo of my screen. And what we're going to do is I'm just going to start loading some data. So here we have the Diffusion console, and underneath our raw data, here is our raw data coming through. This is our 10 currency pairs, each with their own three tiers of prices. Now, when we look at the topic views, we are able to, for example, I think we mentioned, we are able to look at pulling out just the pairs. So we pull out just the pairs of data, which will then give us a view of every currency pair, with each currency pair containing the three tiers of prices. And then we can pull the pairs, using a further view to pull the pairs apart, and then only pull out the tiers of prices. So when we look under tiers, we can then pull out individual current. And so there we have the top tier for Euro Sterling as an example. And when we subscribe to this, we can see here we have where the data is updating, and we only have a single tier for a single currency. Yet this doesn't exist in the raw data. And we can then permission users to only see any node available within the topic tree just by using these topic views. This is another one we have, for example. This is using, let's say we only want to give access to a trader who is only allowed to see any USD currencies, as an example. So here, all we do is we are pulling out the from the pairs. We use standard regular expressions .star USD .star, and we pull it into its own view called USD. So then we only have the currency pairs which have US dollar. And again, users can be permissioned and so forth as needed. So I should say this, and this data is coming from, actually, I should mention a little bit where this data is actually coming from. This data is actually coming from Kafka. And so going slightly briefly off piste here, but we can see with our Kafka adapter, we have a Kafka adapter pulling the data in from a Kafka broker. So this is just an example of how we can pull data in from external sources and then manipulate it on the fly with great ease. So I'm just going to go back to my presentation, if I may, and bear with me let's see, bear with me 2 seconds. Okay, so a little bit about our security model, if I may. So the Diffusion provides 2 APIs for governing access to data. The first is what we will call the authorization API. This defines the roles and what each role is allowed to do. And then we have what we call the authentication API, which is where we define the users and what roles they're entitled to. Both of them are available programmatically. So they can be changed on the fly. We mentioned roles, but I've already shown roles can use regular expressions. So we can use any form of regular expressions to define any part of a topic tree to grant access or to take access away and so forth. And this can all be done, these changes are done immediately. So as soon as access to data has been granted, if a user has subscribed to that tree, the data will immediately start to flow. There's no waiting for a refresh or overnight caching of data or weekend changes. This literally is real-time market data management for the masses. Furthermore, the 2 APIs provide what we call an authentication handler. So this means that we can integrate seamlessly with single sign-on systems, very prevalent, for example, in investment banks. Also, the authentication handler can be used for tracking who is accessing what data. So this means that reports can be generated, for example, for audits to make sure that the system is compliant, But not only that, it also would allow reports to be run, for example, of what users are entitled to see and what they're using. So potential for cost savings here, because you'll be able to identify what data users are not actually interested in, and therefore the permissions can be taken away to save money. And crucially, a point around security is that at the network level, all client-server communication is secured via TLS 1.3. So, and the choice of ciphers used to encrypt the data is completely configurable. This means that there is no need for private lines. We can use this over the internet and so forth. It's completely encrypted with the most secure encryption technologies today. And a little bit then around, and here's a good example of the view of how to configure such security. So we have our role-based security, where we decide exactly what can be done within each role. We'll define the topics. There could be regular expressions in here. A key point here, I think, is when we look at the topics, we see there's read, update, modify, and select. Oh, sorry, read, modify, update, modify, and select. If the user doesn't have the select ability, then they don't even have access to know it's there. So without the select view of a particular topic, the user will not even see it. So data can be hidden from users. Read means that the user is allowed to subscribe to the data. Update means that they're allowed to publish to the data. And modify means they're allowed to change the topic, its properties and so forth. And once we have defined our roles, then we will then associate those roles. Every user will be given roles. And all I mentioned, all of this is done programmatically, can be done programmatically in real time. A little bit then I think we'll talk about about the distribution of diffusion. So diffusion will publish compressed deltas. And this is just done in flight as standard on any type of hardware or virtual machines. With the compression along with the deltas means that our users can enjoy over 98% reduction in bandwidth. And we have a good example here. This is actually from my own laptop from the demo that I've just provided. We can see the delta compression ratio is 98.13. That means that there was over a 98% reduction in the bandwidth published to the client. Now, that means that when we're opening up, we open up to unreliable networks or public networks like the internet. It becomes totally feasible to publish this data because we don't need high bandwidth lines. On this note here, this is a view of what we call a metric collector, but our clients can write their own metric collectors to capture any form of data that as it flows through Diffusion. It becomes part of the Diffusion ecosystem, and it becomes open to all clients, if you like. So it's not just using shall we say Diffusion's monitoring metrics. Clients can write their own metric collectors. And then I think the key point here in the middle is that the client application will always maintains the full state of every instrument that it's subscribing to. So even though Diffusion is only sending compressed deltas over the wire, the client will always have access to the full state. This is done all through the API. So there's no need for clients to maintain their own state. They always have full access to the full image. Diffusion just looks after the compressed deltas over the wire, all done on standard hardware. And another point in terms of how we can distribute data, we have a concept of what we'll call remote servers. Remote servers is a downstream server that can be configured to only subscribe to portions of the upstream topic tree. So this allows very fine control over what data is sent to what remote servers. They can be also created and monitored programmatically as well, so they can be brought up on demand when necessary. And here is an example of a monitoring dashboard. This is the Diffusion console. We see here that we've got complete system metrics, everything at the network level, but also we have session metrics and per topic metrics and so forth. All of this is available off the shelf, but of course, as I mentioned, clients can also define their own metric collectors and integrate it into the ecosystem. One final point I think I'd like to make then is around the consistent use of internal external technology. So what we've gone through so far is that the full end-to-end stack of an electronic trading platform can be written with Diffusion APIs. So in terms of data ingress, all we really need is a specification. So here are some example market data protocols. We also have the internal feeds, for example, that we have written adapters for. And also we have written consumers of static data, like reference data from exchanges and so forth. It takes about 1 to 2 days to write an adapter, as I've already mentioned. There is then this concept of what we call a control client. The control client is a client that sits alongside Diffusion. It can optionally consume from Diffusion or any other source, and it can publish to Diffusion or any other source. Crucially, however, the API provides what we call session locks, which allows for fully resilient and redundant clients. This is all available off the shelf. There's no need to cater for or have to write your own resiliency code. The control clients off the shelf will operate in resilient and redundant quorums or pairs as needed. And then crucially, a new feature that we are releasing in the next release is what we call the Gateway API. The Gateway API allows clients to integrate their own feed adapters into the Diffusion ecosystem. In fact, the Kafka adapter that I demonstrated earlier is an example of an adapter that was written with our Gateway API. It means that your adapters become part of the ecosystem of Diffusion. They can be monitored, they can be configured and controlled within the ecosystem of Diffusion itself. They're not just another process sitting to the side. They actually form part of the full end-to-end system. And then what I would like to do is just touch upon is go back to our diagram that we talked about at the start. So hopefully we've covered each of these challenges sufficiently. So we've talked about market data, how we can model our data structures to be able to send only the data we need to our clients. We've talked about how we can split up, maybe split by regular expression or so forth, and stream only only the data we need to our traders' desks. This, of course, is WebSockets, not as opposed to consuming multicast. So it means that it's our traders are only receiving the data they need to see. We could even have them delayed, so they don't have to pay for the data, or have it data throttled and so forth. If they can consume throttle data and live with throttle data. We've talked about how we can also open up Diffusion to external client order flow. How we could, for example, have used comp IDs or client order IDs and coupled with time series topics to be able to keep a whole history of fixed messaging and on a per order basis. We've looked at how we can disaggregate the data so we can control the data that is sent down to, for example, middle office systems. So they're no longer being inundated with unnecessary data flow. We've looked at how we can segment our data into different types, for example, security status or reference data, so that we can service our algos extremely efficiently. So the algos don't have to keep a stream of a huge data pipe to get the data points it needs to operate. And we've looked at how we can secure our data flow over external networks to the likes of brokers and so forth. So with all of this, this takes us to the full Diffusion ecosystem. Everything you see here in navy is essentially available off the shelf within Diffusion today. The points I would highlight primarily are essentially the libraries available. So Diffusion you can write to Diffusion using Java, JavaScript. There's C, C#, library SDKs available, also iOS and Android. And we also recently released a Python SDK as well. We've also mentioned the various adapters we have available off the shelf today: REST, JMS, Kafka, real-time databases. And the other point I would make here essentially is that we have all of the different messaging mechanisms. So you have fetch response, real-time pub sub, or indeed messaging, allowing different clients to communicate with each other via Diffusion. So in terms of how do we get started with this, then I will just point our audience to our website. You can set up a free Diffusion Cloud instance today for free on our website. There are plenty of webinars available, including how to build a real-time application and so forth, as well as plenty of documentation in our developer hub. You can also download Diffusion from our website. It comes with a free license to install on your own on-premise kit as well. And that takes us to the end of the webinar. So at this point, I would open the open the webinar to the floor if there are any questions. And oh. Can diffusion help reduce data costs? Very good question. I would say the answer there is absolutely yes, in more ways than one. First and foremost, using our modeling, if you like, we can reduce data costs by, well, first of all, we can filter data so that our clients or even our individual traders only see the data they need to do their function, to do their job. So that means that if we have, say, traders we have in, let's say we have traders in London and in Paris and in Frankfurt, or traders in New York and in Chicago, we can send only the data they need. That means we're reducing exchange fees. From a networking perspective, we don't need those huge network pipes because we're sending less data, and the data we are sending is compressed deltas, so over 90% reduction. So it's A, less data, and B, what is sent is significantly smaller. So we can work with much smaller network pipes, and that of course is internal within an institution, but also external out to our external clients. I would also say that using Diffusion, for example, Diffusion's topic views, we can have either throttling or delays. So for the applications that can survive with delayed data, maybe that might be your TickDB or Tick database and so forth, then we don't need to pay exchange fees because the data is delayed. And controversially, I would probably say as well that I would also say using Diffusion's permissioning model, it will allow you to run reports. So anytime there is any compliance reports and so forth, it can all be done automated. And that will, of course, reduce time in terms of effort and so forth to actually demonstrate compliance. So you're saving in staffing costs and so forth by pure automation. And I think it's fair to say that when we automate things, as we've demonstrated here today, hopefully we're automating the complete flow of market data, not just market data, but also reference data, critical for the algos, all fully automated. When we're removing the human element from all of this, not only are we introducing greater efficiencies, but we're also promoting greater consistency. So you get the same experience every time because it's automated, and you're reducing risk of outages or incorrect values and so forth. So there will also be cost savings there as well. And Kira, to your second question, so can you report who isn't looking at topic views they are subscribing to and is costing us license fees? Yes, absolutely. So with Diffusion, we have what we call an authentication handler. And authentication handlers are they can be executed in two ways. There is either before the user subscribes. So essentially, that when a user subscribes to data, the authentication handler is invoked before anything flows. The reason for this is that this allows us to go off to an internal system like single sign-on or to check JWTs and so forth to see, is this user allowed permission for the data? Then there is also an after authentication handler. So there is which is invoked after the subscription has been set up successfully and the data is flowing. So that allows us to do reporting and so forth. So using the combination of authentication handlers, we will be able to run reports based upon what is available on the topic tree, cross-check this with what is available through a user's permission profile, and then using the authentication handlers, we are able to see what the users are subscribing to and cross-check that against what they are permissioned to see. The difference between the two will allow us to highlight parts of the topic tree in Diffusion that the user is not accessing or not using. So that allows us then to basically, for example, obviously speak to the user, of course, be polite and say to them, you're not using this data, we're switching it off and save costs this way. So yes, absolutely, Kieran. Using authentication handlers, we can run reports to see who is entitled to see what data and who is actually using it. Hopefully that answers your question, Kira. And do we have any other questions at this point in time today? Okay, I think if we don't have any further questions, we've reached 45 minutes. Do we use artificial intelligence? That is a good question. Today we don't. I see Alexi has raised your hand up. I'll be with you in 2 seconds, Alexi. Today we don't use artificial intelligence inside Diffusion. Diffusion uses very, I would say it's very smart technology in how it structures data under the hood, and we essentially map things, if you like, in binary, and that's how we're able to use topic views in a very efficient way. But it's not AI or machine learning as we would say today. That said, however, we do have many customers who have AI and machine learning systems that are using Diffusion to disseminate their data to the world. But today we don't use artificial intelligence within Diffusion itself. And Alexi, I think Alexi. 2 seconds. Let's see. Sorry, Rod, I'll be with you in 2 seconds. I just want to. I'm just trying to make sure people can actually talk. Bear with me 2 seconds. Let's see. 2 seconds, Alexia. I'll be with you in 2 seconds as soon as I've figured out how to. Or if you can ask a question, please do ask the question in the Q&A. Is this geared towards hedge funds? So Rod, your question, is this geared towards hedge fund? Do you have any individuals who day trade who use this? The answer, Rod, is it's geared towards essentially all participants in capital markets and other industries, I should say, as well. This presentation has been focused entirely on the capital markets and specifically electronic trading, but it's not focused just towards hedge funds. It's focused towards anyone who has any form of automated trading application. Our customers include hedge funds as well as investment banks. We have retail banks, retail brokers, broker dealers, as well as researchers and so forth, and using Diffusion. So in terms of having individuals who day trade with this, well, yes, we have retail brokers available. Actually, there's a list on our website who their whole platform is based upon Diffusion. So essentially their customer base would be day traders. We also have, even outside of capital markets, we have a large customer base in the e-gaming space. So sportsbook, if you like, as well. Again, sort of analogous a little bit to day trading, if you like. So the answer, Rod, is it's not focused entirely on hedge funds. It's open to the entire capital markets industry. And we have customers right across the whole spectrum. Alexi, sorry, okay, Alexi, your question is, can conflation throttling be done based on field values within the message on the topic? For example, smart throttling. Oh, that's a good question, Alexi. So can conflation throttling be done based on field values within the message on the topic? For example, smart throttling. That is a very good question. I would say okay, so throttle. That is actually, that's an excellent question. So using topic views and using particularly the scalar function that we mentioned earlier, we are able to extract the values. So if you had let's say there was a message that had delay by, and then there was, I don't know, it'd be a numeric number, say 5, and then there was maybe another field would be units, could be seconds or minutes. we can extract those values. Absolutely, they can be extracted. I don't see any technical reason why we couldn't have a topic view, which is delay by and then scalar number and then scalar units. I don't see any reason why that would not work. So that would allow you, Alexi, to send a message to Diffusion, which has those two fields populated, and the topic view would be dynamically updated to reflect the new throttling or delay that you wish. So I don't see any reason why it shouldn't work. I would caveat that I would like, purely just being a professional, I would like to test that myself if I could before promising that it absolutely works. But I don't see any technical reason why such smart throttling wouldn't work off the shelf today. It absolutely should. At the very least, if it doesn't work for whatever reason, I would investigate with our engineering team. But an alternative would be to have a control client consuming the data and updating the topic programmatically. So that definitely would work, and that wouldn't take too long to put together. But to do it just using pure topic views, I don't see why it wouldn't work, but I just need to test it. And Alexi, you've also said that you've mentioned that topics being dynamically created are like views, i.e. pointers rather than data copy. However, when a client consumes a message from that Diffusion topic, the data will have to be instantiated, copied. How do you ensure that memory does not blow up on the client side when this happens? So essentially, the clients receive the view of the data. So under the hood, essentially, under the hood, Diffusion uses what is referred to as CBOR. If you're of the technologists amongst you, you're probably familiar with CBOR, concise binary object representation. So Diffusion essentially is lining all of the data up in a structured form, and then topic views essentially are just piecing it together. The API will, on subscription, the API, assuming that the user has permission to see the data, the API will deliver the initial image, the full content, where it pulls all of the relevant data together and sends the initial to the client. The client's API will receive that initial, and thereafter, the only thing that is sent will be the deltas. So the delta, I should say, can be calculated in two places. The delta can be calculated on the publisher into Diffusion, where the publisher calculates the delta, and then the delta is applied to the underlying data structures. That alleviates the server from having to do delta calculations. Or if the publisher cannot compute the delta, then the server will compute the delta. But crucially, all that is dispatched over the wire to the consuming client will be the changed binary bytes that are required to be sent to the client's view of the world in order to update the client's view of the world to the latest state. So it's not really a case where data is being copied and so forth, and it could impact the client's, shall we say, heap. If you like, the client wouldn't be receiving any further data. It will just overwrite what is in the client's view already. The API will overwrite what is in the client's view with the delta bytes. In fact, I should say the API actually provides two, and this is purely off the shelf how the API works. You will receive the old value and the new value so that you can do the client can do their own comparison. They are able to see what has changed. They can see what has changed themselves. And then when the next values come in, the new value gets moved to old, and then the new value is populated with the change structure. But ultimately, it's not impacting the client's memory. So the client should never have any memory issues. If they can subscribe and they receive the initial images and it doesn't max out their memory, then there will be no further problems because there is no extra memory being used. Because the API essentially is doing all of the necessary overwriting of only the necessary compressed bytes, and all of it is being calculated on the server, if not the publisher. Hopefully that answers your question, Alexi. I'm trying to figure out. Bear with me too. I'm trying to understand if I can open up the webinar to everyone to speak. I don't see an option for it. Okay. I'll have to do this all individually. But I think Alexi, I'm just going through everybody here, allowing everyone to talk.
Hello.
Hello. Yep. Sorry, I'm just allowing everyone to talk. Sorry, I didn't realize. I have to go through every member of the audience to allow to talk.
That's perfect. Thank you very much for your replies. Makes every sense.
Okay, great. Thank you, Alexei. We can send you further details on anything you wish at any point. That's everyone is now permitted to talk as well, so you don't have to type your questions. Feel free to unmute if you have any further questions. Yeah, really, I think as I would sort of move to sort of wrapping up, I would really sort of, I think when we look at if I even just go back to one slide, if I may, I'll just go back to this one slide, and this is sorry, it's no, not this one. Sorry, bear with me 2 seconds. It's this slide here. I put this slide together to try and just instoke some imagination, really, because when we talk about market data, yes, we have market data. We can break it into their individual MIC codes so that individual users only need to see data for certain markets. We've mentioned our regular expressions and how we use the regexes and so forth. We can do that on the first 2 characters of the ISIN code to create individual countries or anything else we wish, or it could be other symbologies, of course. But when we start looking at things like comp IDs and so forth, and using fixed flow, if we couple this with time series topics, a time series topic is a topic that keeps history. We're not wanting to compare ourselves to other messaging protocols, but it's a bit like Kafka offsets. Diffusion will keep the history of the message up to a configurable amount. So we will be able to actually keep, for example, the history of every tag 11, meaning that where essentially we pull out the client order ID and we keep the full history of every client order. So it would allow us to literally extract the full history of every fixed order from the 35 equals D right through to the fully fill and done for day and everything in between. And then when we also talk about splitting up by message type, by the type of the data, having splitting up by, for example, just security status means that we can get our algos the security status changes, like a intraday auction or volatility auction or something. They can be informed immediately without having to consume the huge market data feed, all the orders and trades and everything else. We can deliver just the changes in security status, or if there's a reference data change, we can deliver all the normal, like previous close and so forth. But if there's something changes intraday, we can make sure our algos are updated instantaneously. And all of this is over WebSockets, so we can deliver this data to algo sitting anywhere that we can do essentially a ping or a telnet to. So it's when we look at these use cases, all of this is available today, and all relevant to the electronic trading stack, and potentially solving some problems that our customers may have. So that is everything, I think. So I'll just go back to my last slide, and I think if we're on the hour now, so everyone's entitled to speak. So if there are any further questions, please by all means do raise them now, and if not, then we will wrap up the presentation. I will thank everyone for joining today. I hope you found it to be useful. Thank you very much for your time today.